Okay, so before we begin this video, I just want to remind you that this is a no cell phone zone. So phones should be put away at all times. They need to stay in your backpack until you are completely done with your uh with review 3 as well as any missing work that you have from last week. So this video is going to be going over function notation and functions. We're first going to go ahead and talk about functions. So this should be the cover of your function notation foldable. And just one other thing, we did go ahead and glue these foldables in on Friday. So if you were absent on Friday, these foldables can be found in the Monday folder on the wall. I would advise you to go ahead and grab those, and then once you have completed the notes, you can get with a peer to go ahead and show you how to glue those into your journal and where they should go. So, like I was saying, this is the cover of our function notation foldable. And a function can be thought of as a machine that assigns one output to each input. So here we have the equation f of x equals 3x plus 9. So here we call this f of x. And here you can typically see this as f of x, g of x, h of x. And we saw that a lot when we went over quadratic functions and how they were transformed. Now, this letter f, this is the function name. So remember, like I just said, we can have h of x, g of x. That would be the name of the function. So our function name is f. Now, x is your input. Now, when we are doing function notation or evaluating functions, there is typically a number in place of x. And so, what that tells us to do is whatever number we have in place of x, we would go ahead and substitute that into x in our expression here. And once you do that, when you type that into your calculator, that's going to give you your output. And just so you know, our output is our y value. So those are the parts of the equation. So let's go ahead and get into number 1. So it says if f of x equals 12 times 4 minus x, what is the value of f of negative 5? So with this problem, I'm going to go ahead and show you 3 different ways on how to solve it. The first is going to be algebraically. So solving this algebraically, again, I'm finding the value of f of negative 5. So here, when I am comparing f of negative 5 to f of x, I notice that negative 5 is in place of x. So what I'm going to do is anytime I see an x value, I'm going to go ahead and replace it with negative 5. So this is f of negative 5 equals 12, parentheses 4, minus, now I come across an x value. So I'm going to go ahead and substitute that in with negative 5. And now all I have to do is type that into my calculator. So I'm going to go ahead and press the home button, open up a calculator window, and I'm typing in 12, parentheses, 4, minus, open up parentheses, negative 5, and then double parentheses. And when I press enter, I end up getting 108. So here my answer would be D. But again, I'm going to show you 3 different ways on how to do this. So then the next would be using your graphing window. So I'm going to go ahead and press the home button, and I'm going to open up a graphing window. And I'm going to go ahead and type in 12, parentheses, 4, minus x. Now, when you do this graphically, you are only typing in the equation that was given to you. You're not typing it in with the value or with negative 5 being substituted in. So when you press enter, you'll go ahead and press Control T. And from here, I'm going to go to where x is negative 5. So I'm going to go ahead and press on the up button until I get to negative 5. And you're going to also see here that I get 108. Okay, now for the last method, you're going to use your calculator. And this is going to be the store feature. So I'm going to go ahead and write calculator. And I'm going to write store. So our first step is to store negative 5. So the way we're going to do that is we're going to go ahead and type -5. And then we're going to go ahead and press Control. So we're pressing Control and then VAR. And what that's going to do is that's going to put an arrow on your screen. And if you notice above the VAR button, it says STO. So STO stands for store. So once you have that on your screen, you're going to go ahead and press the letter X. And basically just press enter. Oops. Go ahead and press enter on your calculator, and it's going to store -5 in place of X. So now what you can do for step 2 is to just type the equation. You're going to type the equation that was given to you into the calculator. So you're just typing in 12 parentheses 4 minus X, close parentheses. Go ahead and press enter, and you get back 108 as well. So again, those were 3 different methods on how to go about solving a function notation problem. I honestly probably think that y'all are most likely going to go ahead and use the store feature. So I'll do one more question doing the algebraic method if you prefer to do that. But I most likely am going to go ahead and use the store feature for the entirety of the notes. Okay, so let's go ahead and move on to number 2. So number 2 says a bicycle shop determines their weekly profit from the function p of x equals 1.7x squared minus 6x. If p of x represents the profit in dollars and x represents the number of bicycles sold, we want to find the total profit if the shop sells 74 bicycles in a week. So first off, we want to identify our variables. So it says p of x stands for profit. So in our equation, p of x is profit. That's our money in dollars, and X represents the number of bicycles sold. So when I come down to my last part of the sentence, it says find the total profit if the shop sells 74 bicycles. So the number of bicycles is X. So that means anywhere I see an X, I'm going to go ahead and substitute in with 74. So I'm going to go ahead and start off by doing this algebraically. So I have P of 74 equals 1.7 times 74 squared minus 6 times 74. And then all I would have to do is type that into my calculator. So 1.7 parentheses 74 squared minus 6 parentheses 74. Pressing enter, we get 8,865.2. Now remember, our output is talking about the profit in dollars. So this answer here is in dollars. So this is going to be, I'm going to put the dollar sign, 8,865.2. And also remember, when we're talking about money, we have 2 decimal places. So I'm going to go ahead and add a 0 behind the 2. So that was doing it algebraically. If you preferred the store feature, you can go ahead and press 74, Control Store, type in the letter X, and this is now going to change your stored feature to 74. And then I'm going to go ahead and type in the equation. So 1.7x squared minus 6x. And when you press enter, you're also going to get the same thing back, 8,865.2. So that's number 2. Let's go ahead and take a look at number 3. So number 3 says the graph shows the quadratic function f, and we want to go ahead and find f of -4. So when you're trying to find f of -4 from a graph, basically what that means is it is asking you what is the y value for an x value of -4. So I am looking for the output because my input is -4, my output or my y value. So basically, I want to complete this coordinate, -4, comma, what? So I'm going to go over to my x-axis, and I'm going to go to -4. I'm going to go up to hit my graph, Hitting my graph, I'm going to go over to my y-axis, and I'm going to see that whenever x is -4, its y value is a +3. So here, f of -4 is equal to 3. Okay, number 4, given the function below, we want to find the value of f of 3. So again, I'm going to go ahead and start doing this using the store feature. And I'm going to go ahead and type in 3, control store, and I am substituting in 3 for x. So I'm going to go ahead and identify that variable x in my calculator and press enter. So now anytime I type in an x, it's going to substitute it with the 3. So all I now have to do is type in my function. So control divide, 2 on top, 3 on the bottom, step out of my fraction, parentheses, x minus 9, close your parentheses, squared, plus 6. And when you do that, you're going to get back 30. So here, my answer is 30. If you were doing this algebraically, this is how you should have typed it into your calculator. And you would have also gotten back 30. And I can do that real quick before we move on, for those of you that prefer the algebraic method. Oops. 3 minus 9 squared plus 6. Again, you're going to get back 30. Okay, so moving on to number 5. A function is shown. We have f of x equals 7 minus 4x, and we want to find the value of f of -5. So again here, I'm replacing anywhere I see an x with -5. So I'm going to start off using the store feature. I'm going to go ahead and store -5 in place of x. So -5, control store. We're replacing it for x, pressing enter. And now all you have to do is type in the equation. So 7 minus 4x gives us 27. So here my answer is A. Again, if you wanted to do this algebraically, we would write f of -5 equals 7 minus 4, parentheses, -5, and you can just go ahead and type that in, and you would see that you would end up getting the same exact answer that we got by storing. Again, you can choose whichever method that you want to use. Okay, so that's going to go ahead and complete your function notation foldable, and we're going to go ahead and move on to our function or not a function foldable. Okay, so let's go ahead and get into our functions foldable. So first off, a function is where each x value has exactly one y value. So today we're going to be looking at coordinates, tables, mappings, and graphs to determine if they are functions or not. So let's go ahead and start off by looking at coordinates. So remember that each coordinate has an x and y value. So basically, when I'm determining if a representation is a function or not, that just means that x's can't repeat. So when I look at my representation here, my set of ordered pairs, I'm looking at my x values. We have 8, -7, and 6. None of my x values repeat, so that means that this is a function. Okay, next we want to look at tables. So anytime I'm trying to determine if a function or if a representation is a function or not, I automatically go ahead and cross out our y values because they're not important. I'm only looking at my x's. We have -2, 0, 3, 6, and 8. None of them repeat, so that tells me that this is a function. Lastly, we want to go ahead and look at mappings. So with mappings, a quick way to determine if it is a function is if you have only one line coming from an x value. If you have more than one line coming from an x, that would automatically make it not a function. So here I have 6.2 paired with 3. I only have one line coming from 6.2. I have one line coming from 8 and one line coming from 11. So that tells me that this mapping is a function. Now remember, with mappings, a quick kind of thing you can reference from 8th grade is the bus stop analogy. So you can only get off at one bus stop. You can't get off at two, because once you're off the bus, you're off the bus. Now for graphs, remember, we want to check to see if it passes the vertical line test. So basically what the vertical line test is we will draw a vertical line going through our graph. Now, if it touches once, that means it passes the vertical line test. So if I were to have only performed the vertical line test in the section that I just drew my line in, it would pass. However, you always have to check multiple parts of your graph. So if I were to do the vertical line test here, it would pass because it only touches once. But once I get here, I end up seeing that it touches the graph twice. So that makes this not a function. Now for the remainder of these notes, I don't need a calculator, so I'm going to go ahead and make my screen bigger. Okay, let's take a look at number 1. So number 1 says, which set of ordered pairs represents a function? So again, we're only looking at our x values when we are trying to determine if a set of coordinates is a function or not. So for A, I have negative 1.5, negative 2.5, 0, and 3.5 in place of x. None of my x values repeat, so that means that number 1 is a function. Looking at B, we have 2, 6, negative 2, 6, and 8. Here I see that 6 repeats, so this is not a function. C, we have 7, 7, 5, 5, and 3. Seeing that my 7s repeat along with my 5s, this means that this is not a function. And lastly, D, we have 1.2, 2.2, 3.2, and 3.2. I see that 3.2 repeats, so again, that means that this is not a function. So again, the question says, which set of ordered pairs represents a function? So here, the only set of ordered pairs that represents a function is going to be A. Moving on to number 2, it says which mapping does not represent y as a function of x. So remember, in order for a mapping to not be a function, you have to have more than one line coming from an x value. So for A, I have one line coming from the x value of 3. I have one line coming from negative 2, one line coming from 7, and one line coming from negative 4. So that means A is a function, and that means it's not my answer. For B, we have one line coming from 1.5, one line coming from 3, one line coming from 4.5, and one line coming from 6. So again, because you only have one line coming from each x value, this means that it is a function. For C, we have one line coming from negative 8, one line coming from 2, and one line coming from 5. So again, because you only have one line coming from an x value, that again tells you this is a function. Lastly, D, you have actually two lines coming from the x value of 25. So because you have two lines here coming from one x value, this tells you this is not a function, and my answer is D. Moving on to 3, it says which table represents a function. So again, anytime I'm looking at a table to determine if it is a function, I go ahead and I cross out my y values. They're not important because I'm only checking to see if my x values repeat. So for table A, if I look at my x's, we have negative 0.5, 6.2, 1.5, and negative 0.5. I notice that negative 0.5 repeats, so table A is not a function. If I look at table B, I have negative 12, 32, 14, and negative 11. I do not have an x value that repeats, so this would be a function. So the only table that represents a function is table B. So my answer is table B only. Lastly, number 4, which graph represents y as a function of x? So here I'm checking to see which one passes the vertical line test. So if I look at F and I draw a vertical line, I see that it hits twice. So this is not a function. H, if I draw a vertical line, I see that it passes through 3 times. So this is not a function. For G, if I draw a vertical line, Again, it hits twice. That means this is not a function. And lastly, J. If I draw a vertical line here, I see it touches one time. If I draw a vertical line here, passes or touches the graph one time. If I do the vertical line test here, again touches one time. If I do it here, again touches one time. So this graph passes the vertical line test and it is a function. Therefore, my answer is J. So that is going to go ahead and complete your function foldable. Now I'm going to go ahead and do number 11 off of your assignment. So, number 11 says the ordered pair below represents a function. And so it gives us a set of ordered pairs, and we want to know which of the following could be the value of n. So, basically, what I'm trying to do here is I'm trying to see which of these numbers I can put in place of n into my set of ordered pairs and it would still make it a function. So here I first need to start off by checking to see what x values I already have. So again, obviously I'm going to replace n with one of these numbers. We have 3, 1, and 4. So the only x values that I already have are 3, 1, and 4. So if I were to put any of those numbers in place of n, it would automatically make it not a function. So when I look at my answer choices, I notice that I have 3, 1, and 4 as options for my answer. So I'm going to automatically go ahead and cross those out because if I were to replace them for n, it would automatically make it not a function. So the only answer choice that I have left is 2. So if I were to put a 2 in place of n, I would have 2, 3, 1, and 4 as my x values, and it would stay a function. So here my answer is B. So go ahead and finish up your assignment. If you feel like this video went a little too fast, it will be linked in Schoology for you to review again. And just as a reminder, once you have completed your assignment, make sure you're completing anything else you are missing. And again, phones should not be out unless you are completely done with everything.